here shortly. Hello, so, oh, there's somebody in the waiting room. Bring him in. Bring him in before we get started, and then we'll get started. Hi, Burke. We were just getting started. I just hit record a couple seconds before the computer beeped at me, which is a nice segue into tonight's topic. The computer beeped at me. There was a lot of things that had to happen in order for that sound to show up in my earphones, right? There's the whole network connection, because I believe you said you're over in New Albany. So you had to, over there in New Albany, you had to log on from your computer, send signals around, eventually to my router over here, and the laptop, and something that had to, register that signal was coming in, interpret what it means, what that signal means, a particular set of ones and zeros coming across that, coming through the air and being picked up on the network card, where that meant that somebody was arriving to the Zoom call, which is a piece of software running on my Windows 10 operating system based laptop. I don't think that's the right way to say that, but running on that software, that piece of software on my computer, which isn't the only piece of software running on the computer. So something had to identify that went with Zoom instead of the browsers open right now. Behind the Zoom window, the Google Chrome browser's open. So I had to identify that particular set of ones and zeros went with this piece of software, and then send a new signal over to the Bluetooth, down the Bluetooth line, so that my headphones would make a beeping noise and let me know you were here. That's kind of a complicated thing. And that was a very broad summary of it, right? There's a lot of fine details that skipped over there. And that's one of the topics for tonight. Obviously, from that quick summary, that's a somewhat complex topic, so we're just going to quickly overview it. But the thing that tied all those different components together, the network, the Bluetooth, the router for that network, the Bluetooth network going to my headphones and microphone, the image on the screen, the button I clicked whenever in order to let you into the Zoom call. All of that stuff needs tied together. And the thing that ties everything together is the operating system. Whoops, that chalk broke. I bought a bunch of chalk from the Dollar Tree not too long ago. And I think I might just open one of the boxes from the Dollar Tree. It looks the same as the other boxes, the boxes from Walmart, but the chalk sure breaks a whole lot easier. Anyway, operating systems. It's the thing that ties the pieces together. Or more formally, the definition I wrote in my notes here is it connects software to the hardware and synchronizes everything. So all that stuff I just described, you doing stuff on your computer over in New Albany, which then goes through router and servers and eventually makes it over to my router and my computer, which identified that signal as having to do with the Zoom software, send a signal to the Bluetooth to make a beeping noise, let me know you were here, and clicking the button on the mouse to actually moving the mouse to the right spot and clicking the button, then bringing you in so that you could see the video being streamed and hear what I'm saying. There's a lot of stuff that needs to happen. a lot of different hardware there, routers and buttons and keyboards and screens. And that's just the top level visible stuff, the things we're interacting with. There's a lot of stuff inside there as well. It all needs synchronized together. And the operating system is what does that. So all operating systems have a few things in common. So there's a few pieces here, and personally, I like to visualize stuff, even if it's sort of abstract concepts. I like to have something in the back of my mind to visualize stuff. So I'm going to draw a little shape here to kind of go along those lines. Because first thing that one of the many things the operating system needs to do is manage memory. Our working memory, the ones and zeros constantly changing, so the stuff's adapting, right? It's not just a machine that comes on and stays on until we turn it off. It changes along the way. And what's changing is the things moving in and out of random access memory. Our working bits is one way to do that. And obviously that's going to need connected to the instructions. So the back here, the processor instructions. The processor working through all those instructions. I mentioned the network. I'll kind of abbreviate it there. We're in that room there at the bottom of the board. But connect to some network. That might be necessary. In particular, it needs to identify and communicate with the network, right? If I share my screen, I bet there's a lot of things to see. If I do a quick screen share and come over here and click on the Wi-Fi button, I think everybody's familiar with that in our society. There are 4 different networks here. 2 of these are here at my house. Only 2 of those are at my house. But from those 4 that showed up on that list, the local operating system has to know which one of those to work with, which one of those it's working with without any signals being interfered and everything being synchronized to work together. I also have to work, whoops. Yep, that is a very lousy piece of chalk. I just broke like 3 times. I'll try a different one. Maybe I'll have better luck with a different piece of chalk. It has to work with files because RAMs are working memory. And if we're doing something on a computer, there's a good chance we want to keep stuff around, right? We want to work for a little while, go take a lunch break and have the stuff that we were working on before lunch there when we get back. So we need to store it somewhere. So there's going to be file storage as well. And all of this is happening on physical hardware. So we also have devices and peripherals, things plugged into the machine. Like that example I started out with, clicking the button on the mouse with the mouse pad on my laptop, that's connected into that device. But my microphone over here, where I heard the beeping sound to know somebody was joining the Zoom call, that's a peripheral device. I picked this up a year and a half after I bought that laptop, and it worked perfectly with it. So we have to organize all this stuff. And one other component that all the operating systems need to interact with is I keep mentioning doing stuff, which means a human's going to interact with this as well. So all of this somehow has to be connected back to a user interface. Yep, I think I grabbed a box of the Dollar Tree chalk again. I'm gonna switch out boxes and try chalk from this different one. I should have thrown all those away when I realized that it wasn't gonna work. And so we have all these different pieces that kind of go together, and I'm sort of a visual learner, so I like to picture this as maybe like a pyramid. If I can draw a pyramid shape. I guess it didn't come out so good. Yeah, the shape didn't come out so good, but something like a pyramid. There's five corners on the bottom, so not a square pyramid, but a pentagonal pyramid with the user interface at the top. So everything has to operate together and be focused back to where the human can interact with it. I'll do a better picture. Maybe if I start with the something like that. I'm used to drawing pyramids with four corners, not five, so it didn't flow out very well. But at least in my mind, that gives me a shape that I can connect it to and help visualize the operating system as sort of this big pyramid, and then all the corners up at the top, everything focuses to the user interface where the human interacts with it, and all of that coordination between the different components work together. Which is a couple other things I had in the notes, just some quick pass, like everything else in this class is sort of preview mode, so we're not getting super detailed, but that is what all operating systems have in common. So that's just the very basic core, right? Most of the stuff has more than that, and that's how we choose the one we want, because it has more than just those basic components. But from that list, well, the first thing I mentioned there, memory management. The computer needs to divide up memory and decide which pieces of software get to use that. Because RAM, that is actual hardware. That's a physical component. It's just a place to store a lot of bits that's not going to wear out. The more stable type of memory wears out quicker. So we use that more stable ones for ROM, read-only memory. That way we only have to write it once, and then it doesn't change. Or a lot of ROM is actually manufactured to have that memory directly in it, but it doesn't change. It's stable. RAM is going to change constantly, so the computer has to decide what gets what part of RAM. Typically, we'll see that drawn as a box, and the computer is going to partition it off and assign it. So maybe up here at the top, all of this is reserved. Because obviously the computer is going to need a little bit of RAM for itself in order to coordinate all of these things. And then there's, obviously there's going to be some software running on that machine to get things done. So the computer is going to come in here and just pick some chunk of memory. I'll put little dots here to kind of distinguish that one. And the computer's going to be like, okay, process A can get this chunk of memory. Maybe that goes from bit 248 to, 1,479. So that's something software needs to do whenever it starts to run. It needs to tell the computer how much RAM it needs so that the computer can partition off a block and let it use that. Then maybe a few minutes later, a second process starts up. So the computer is going to partition off some chunk there. I'll do it with little dots, or big dots this time. The computer writes off a partition and says, okay, so process B starts, like, yeah, I need 3,000 bytes in memory, 3 kilobytes in memory. So the computer looks at the RAM that's available and says, okay, you can use from, well, to keep the math easy, I'll say, you can go from bit 5,000 to bit, whatever I just said, I think I said 8,000. So 7,999. Needs 3,000 bytes, so the computer is going to reserve 3,000 bytes, and the computer will keep track of where all that is. And then when whoever wrote the software probably added some useful names that the computer connects those useful names to the numbers in memory, but it partitions off that block and assigns it. It's like, okay, a process B can have this partition in memory and keeps everything coordinated like that, synchronizes it all together. Maybe a short time later, process A finishes. Maybe it was just something, maybe it was just a short thing checking for updates or something, but it finishes. So I'll put that on here so that hopefully these colors are showing up. Does that show up different? It doesn't look very different. Let me try this one. Okay, that looks more different than the white. So process A finishes. Maybe it was just checking for updates or something. So at that point, the computer can basically clear that memory out. That's available for something else to use. And then another process is going to start up. Well, that memory is open now. So the computer's like, okay, there's a chunk right here that can be used. And give that to, say, process C. And it's constantly switching out what's being used. At times, it might have to get completely emptied. Things need to shuffled around. Maybe something comes in and it would need more space than is available here. From here down to the middle of this, and everything needs shuffled around. So the computer, the operating system has to manage all that. And we'll often see it drawn in diagrams like this. I did want to go ahead and draw that diagram. The next little section is with processing, which there's really always three parts. We think of it as a big complicated thing, but the CPU is really only doing three things over and over and over again. Sometimes you'll see the list with four. I usually go with three. I'll mark the fourth one on here. So over and over and over again, the CPU is just running this cycle of fetch, increment, and execute. And sometimes you'll see, depending on the reference material, you might see a fourth one here of decode. And inside, going along with the synchronization point, there's just a counter constantly running. That's one of the core parts of the CPU. There's the clock and the counter. And the counter tells the computer what the next instruction is going to be. So it's going to look at the counter, fetch the next instruction, then increment the instruction counter so that it's ready to do that again, and then execute this instruction it just retrieved and stuck in RAM somewhere. It's gonna, so up here in this little block here, the computer's going to jump over to storage or wherever that's held. I'll put a block here. Maybe it's this instruction. So the CPU is going to fetch that, bring that up to the working area, increment the counter so that it's ready to carry out the next step, and then execute whatever that instruction was, and then clear out this, then afterwards clear out that spot so that it can be used again. And depending on the reference material you look at, you might see decode as a fourth step in there. When I learned this, decode was a substep, was just put in as a substep of execute, because that's part of carrying out the instruction is figuring out what that instruction is, decoding what it means. So you might see that as a 3 or 4 step list, but that's what CPUs do over and over and over again. So the operating system has to make sure that stays in order, that it continues in the order it's supposed to go in. And in most machines, what we think of when we say computer, there's going to be parallel processing and multi-threading. So we might have more than one, we're going to have more than one processor doing this. And then we'll break all our instructions up into subsets of instructions to smaller micro instructions that we can carry out separately. And the operating system is what kind of synchronizes it and ties it all together. The rest of the next one I can draw is sort of one big picture. Is okay if I erase this half over here? The picture I tried to draw there didn't come out very well anyway. But yeah, just sort of the broad summary of what an operating system is. It's what connects the software to the hardware and synchronizes everything. And I'm a very visual person, so at least in my mind, I kind of visualize a pyramid shape for an operating system. And at each corner is one of the main components of it. But trying to put that on the board here didn't work out so well. I guess I need to practice drawing those five corner pyramids before the next time I try to draw one on the board. The next picture I can draw a lot quicker because, well, we're talking about computers here, and just in the broad summary, it's easiest just to think about the computers we use daily, the basic desktop computers. We'll have some sort of desktop system. Maybe a monitor over here, keyboard, and a mouse. Some of our basic parts. I'll put some buttons on the mouse. As you can see, those I've drawn those a few more times in that pyramid. That's usually something just in the back of my mind. But those other parts that I mentioned, the computer needs to keep track of those. So like file management, connecting the file management to the RAM and the processing. I guess this big purple arrow I drew here might have been better pointing this way. Make sure I'm tying all these pieces together. So it's going to fetch that instruction, increment the counter so that it's ready for the next instruction, and then execute that instruction. Does anybody have a thought as to why that order is important? Like increment, couldn't we do that afterwards? And not necessarily safely though, right? We could increment down here, but what if the instruction we're carrying out? Yeah, there's a comment in there about sorting through the data, keeping it sorted and in the right order. Yeah, I was going to say, like, the instruction that's going to be carried out, maybe the next instruction, the one we just fetched, is to go back and repeat the last 5 steps. And if we, then we can just bounce our counter back. But if it increments afterwards, this instruction says repeats the last 5 steps, then it goes up. Then when we go back and try to repeat, we're going to be off by 1. So the ordering stuff's important. And that's just the cycle the CPUs do over and over and over again. Fetching things from RAM, carrying out that instruction, and then fetching the next one. So that's happening inside that big box sitting on the desk. And along with that, somewhere in here is a hard drive. I'll draw something close to the standard symbol for storage. Over here, we have some sort of storage device. So we're going to need a connection going between storage and RAM. Because we work in RAM, but we keep things around over on the hard drive, and they're 2 separate pieces. So we have to send them back and forth as needed. And obviously, there's some other parts here. Somewhere in there, there's power. I'll try drawing a lightning bolt. I guess that kind of works for symbol. The operating system has to make sure all the power is regulated correctly if there's any problems. I did that a couple days ago. I was just messing around with circuits and needed some power for something. And I just took one of the extra USB cords sitting around, cut that, and um, went ahead and got the wires ready, started on some nice solid connections to it where I could tie that into the circuit, and then powered the circuit, did some stuff. Then a few minutes later, I was working on a different step on the same project and went to plug a part component into the computer with the USB cable. And without thinking about what I had just did, I grabbed that USB cable that was connected to become just power running directly into a circuit. So like I cut it and then soldered it into another circuit. And the computer immediately detected that and panicked and kind of refused to do anything until I restarted the computer. It wouldn't let me use any USB ports until I restarted the computer. So it has to detect that power regulation. That's an important thing. It has to connect to all these devices. Right? It has to move stuff back and forth between RAM and files. This is like the user interface components I mentioned. We want to see what's going on the computer. We need to see that. The keyboard, we have to give stuff, feed instructions to the computer. We'll like manually override that nice ordered list of instructions and tell the computer which one we want it to carry out next. And we do that with the mouse and the keyboard, which is another thing the computer needs to do. Is it needs to assign the operating system, sorry, not the computer, the operating system needs to give priorities to these things, right? When we click the mouse, we expect results immediately. When we click the mouse, we don't expect it to just be put on the list of things to do later. It needs to interrupt whatever the operating system is doing and immediately carry out that button click and display something on the screen so that we know it happened. So there's different priority levels between all the devices and all the memory management and all the processing that's running through the CPU. So the operating system is kind of what organizes that. I had a couple more things on here, a list of vocabulary terms, but I think I'm going to abbreviate that because this is kind of a preview mode. And as I'm looking at the board now, I know I'm a very visual person, and that's you'll probably heard those words, things like, I'll read them off. Yeah, I know I'm a very visual person, so I would like to leave the pictures on the end with the pictures instead of the words, but things like throughput, the number of jobs processed in the unit of time, resource utilization, how much each one of our units is contributing to the overall performance. Right? Is our screen speeding things up or slowing it down? Maybe there's a problem in RAM. An old computer and a lot of dust has gotten in there and settled around the RAM chip and caused some bottlenecks that slow things down. Availability, I guess I'll read off the technical definition of that because it doesn't get used in like advertising so much. But as we're getting into IT stuff, availability is the likelihood that a resource will be available when the system needs it. So if we click on our mouse, telling the computer to do something, and it's going to need a big spot over in RAM, what is the likelihood that that's going to be available, right? That is something that we know about very well, right? If I share my screen, I can pull up an example of that we've seen many, many times. Here in a Zoom call, Zoom's kind of a RAM hog, right? When Zoom started up and the operating system asked Zoom how much RAM it needed, Zoom probably said all of it. And the thing is, Zoom's not the only software that would do that. But then during the Zoom call, we need to look up something up on the internet and come over here and open a browser. think we've all seen what happens more than once in that case, right? We wait and wait and wait, and I clicked on some stuff to show that even the mouse click was going really, really slow. Because Zoom and Google Chrome are both kind of RAM hogs. When the operating system asks them how much of memory they need, they'll just be like, yeah, all of it. So then when another one starts and asks for all of it, it gets to be a bit of a problem. So I'm going to kind of skip those vocabulary terms and lead to the picture one, because most of them are things that you've heard in advertising and stuff. It's not necessarily new words that we need to pick up. And keeping track of this, well, it's kind of shown over here. This stuff happens over and over and over again. So it's looping. And one of the key components by which operating systems run is on feedback loops. Most of us are familiar with audio feedback, which is typically an annoyance. A lot of musicians, the two that always spring first to my mind are like Jimi Hendrix and Tom Morello, where they learned to work with the audio feedback, and then it was just another note that the guitar played. But usually audio feedback's an annoyance, and that's what we typically think of. But feedback just means output goes to the input. So the previous output becomes the new input. So in general, feedback is a good thing, and operating systems rely heavily on it. So they're constantly running feedback loops. I'll draw a little one over here. So one of the things the operating system is going to do is monitor resource response time. That example I just pulled up, whenever running a Zoom call, go to open Google Chrome, everything slows down for a minute. I click on something with the mouse. Well, the computer's constantly monitoring that because the mouse has very, very high priority. And it's going to quickly notice that something seems wrong with that response time. So our flow charts with operating systems tend to look like this. It's going to come down to some sort of selection structure. It needs to make a choice. I'll write too busy here. So the selection, the diamond shapes, that's where it makes selections. The computer's monitoring that response time. It looked at how long it took that mouse click I made to actually go through and have a reaction. Which with Zoom and Google Chrome running, the answer to that question is definitely a yes. It's something's way too busy. So in that case, the operating system needs to do something. So that yes is going to come over to a block to decrease utilization. So it's going to cut some things out. Right? Zoom was running first, so Zoom would have already asked for all the RAM that was available. The computer monitors all the timing. The operating system monitors all the timing. Notice that it took too long to do something. So it's going to be like, oh, well, sorry, Zoom, you don't get all the memory, and yank some of that back to give it to other things. And then come back around as a feedback loop, and then go right back into monitoring it. At other times, the computer is just constantly doing that. That's just one of the instructions that periodically gets fetched and executed. And maybe nothing's going on the computer. It's just sitting there idling. So it's definitely not too busy. So whenever the answer is no, well, there's probably some stuff on a waiting list so that it can increase utilization. We can just about guarantee that, right? Somewhere in the background, some piece or another of software on our systems has already told the operating system that the next chance it gets, it wants to look for updates. We know there's stuff constantly doing that. So whenever the response time shows that it's not very busy. It's going to take this branch of the flow chart, run some of those programs over there waiting to run, and then go right back to monitoring. So flowcharts on an operating system often end up looking like that with the feedback loops, where it runs through, but when we get to the end, it's not a stop point. The end just comes right back to the beginning. That was kind of some of the key points I wanted to talk about on that. Oh, what time was it? 6:37. Yeah, I got a few points out of there because it seemed to be running long. And there was another thing to talk about this evening as well. Yeah, does anybody have any questions about that? Just sort of a quick overview pass of the things that an operating system needs to do. Has all these different components, the user interface stuff, the storage and the power, the temperature and cooling, right? That's computers have come a long way since the 40s and 50s. Right? We always hear about, here it said is computers were the size of a house, and that's not really true. The computer, what was needed to carry out these steps was about the size of a desk. The radiator to cool it off was the size of a house. Because it's really easy to put a heating coil, a little bitty heating coil next to a mercury switch, or next to a piece of mercury and melt that mercury to turn on the switch. But it's a little hard, it takes a little bit more to cool it back off. So that was the big, I guess that should be in there somewhere too. The power regulation, temperature regulation, file storage, user interface, the memory, the CPU, all of that needs tied together. Oh, and networking. I guess I can draw that picture, because then we need to come out and connect to the rest of the world. If I can quickly draw a picture of the world. Something like that. Yeah, we got to come out and connect to the rest of the world too. That's very important in our modern society. So the operating system has a lot of tasks to carry out. I already erased it, but it's the thing that connects the software, all of this stuff, to the hardware and synchronizes everything together so that it all works in unison. There's a lot going on in it, right? It's not something that fits nicely in a preview. So kind of preview it here, and then in all of your classes, as you go through all your classes, there's not a particular operating system class anymore, which struck me as really strange. When I first started as a student at Ivy Tech back in 2011, one of the classes I had to take was explicitly operating systems. That was just the name of the class, and just learn those general concepts before focusing on other ones. But that's not a class anymore. So as you move through all your other classes, try to keep this in the back of your mind somewhere about the operating system, tying all of it together, and see if you can form and slowly develop a better picture of how everything ties together. As you learn new concepts, make sure they fit into that categorical understanding of an operating system in your mind and how the things tie together. Because the general stuff there doesn't seem to be a class on it anymore. It got replaced with something else, which I'm not sure what replaced it, or if they just dropped it in general. But that was kind of the points I wanted to make about an operating system. Does anybody have any questions about those? Oh, I missed something in the chat room. Oh, you say you were having trouble reading the charts. Sorry, which one? Oh, the flow chart. So sorry, I was running out of room. So I put too busy here. So it's just constantly monitoring the response time. Like I click the mouse, and from how long does it take from the time when I click the mouse until the process that clicking the mouse in that spot initiated finishes running. So how long does that take? Our total response time, the computer just has another clock running. It looks to see how long that takes, and then just ask the question: is that too long? If that seemed to be too long for the standard throughput goals that it's trying to meet, that's either a yes or no thing. And if the answer is yes, that took too long, it's going to decrease utilization. So everything that's running has to back off a little and release some of those resources so they can be running again. And over on this side, that said, if the answer is no, that happened very, very quickly. Happened so quickly, there's still plenty of time to do other stuff. It'll increase utilization because there's probably some things waiting on it. Sorry, I didn't see that pop up in the chat room when you asked it. It didn't auto scroll. Yeah, okay, that time it scrolls. Yeah, usually it auto scrolls, so whenever something new comes up, I see the latest one. And there's a handful of operating systems that we work with. I've pulled up a couple in this class already and was actually going to do so on the next part tonight. I'll go ahead and share my screen. So on my main computer that I use here is a PC running Windows 10. And we can get to the system information. So I hit Windows X and then Y to get all the information about the system. So it's got some sort of name. And here's those things, different parts like I was talking about. It's got some sort of processor running. This computer is a couple years old, so kind of a small processor. A little out of date, I guess. Probably about time to replace it. See how much memory there is, the processor that's running, a description of the system, the user interface, the pen, touchpad systems, the touch screen along with the keyboards and other things, and all the information about that so we can see what it is. But that's not our only operating system. When we've looked at the foundational skills assignments, which we're getting ready to do again here in a moment, I've also grabbed a couple of my other machines. The Chromebook, those are getting more and more popular. And Chromebook actually has two systems running on it. It has the Chrome OS, and then they put a virtual Linux system on it as well. The stuff on the Ivy Learn, the learning materials for this week talks about virtual systems, and in particular, there's a video introducing this software called Virtualbox, and that is a really, really nice thing while you're learning about computers. A virtual machine is just a fake system, right? So my computer, which is a couple years old here, and I don't think there's enough room on a hard drive to install anything, otherwise I would be doing that for the example. We just install a virtual machine, and then my Windows 10 system just sits in the background while this fake machine runs, which is a great learning tool because then you can experiment, try things, make changes, see what happens. And if you break it, you're breaking a fake machine, so you can just delete it and install a new one, as opposed to, if you break your actual system, you might end up having to replace the computer. So virtual machines are really, really nice. I made sure that video was on there for getting started in the Virtualbox and just learning with fake machines. That way there's no worry about breaking them. You can just, experiment around and do different things. Whenever we've been looking at some of the software, periodically grab my Chromebook, Chrome OS, and it has a virtual machine running on it, running Linux. They just come that way. There's also a virtual machine on Chromebooks running Android. the operating system for the phone, right? It's or iOS, which I don't have one of those, but they all have to do these same things, tie all those different pieces together and synchronize them so that they work together. It doesn't just crash. I've also got the MacBook that I only have because I found it on a really, really cheap deal. But that was pretty much what I had wanted to say about operating systems. The other thing for tonight was on that list of foundational skills, those assignments every week that seem to be worth the most points when you look at the discussion board, the quizzes, and how the point breakdown is. The most points are assigned to those foundational skills, which is just kind of basic computer usage, right? We want to make sure you know how to use those so that in the rest of the classes, it can be taken for granted. And the one we're going to look at tonight is a big one because it is one that will definitely be used over and over and over again in a lot of your classes. Some of your classes might use it for every single class lecture. And that is presentation software. The main one is PowerPoint. So it's kind of become one of those words, kind of like when we say Google it when we mean search for it. And PowerPoint's the same way. No matter which software we're actually using, there's a good chance we're going to say we're making a PowerPoint, no matter which one we're actually using. So if you have Windows and we get Microsoft Office free here as students. So the little red circle with a P on it, it's PowerPoint. It's presentation software. It's the sort of thing, it's designed to express a point. Really, it's to accompany a speech was the original design for it. But it has grown into a little bit more than that. We're going to look at a couple of features. So you probably don't want to start with a white one, right? I think everybody has seen that. The presentation, somebody giving a speech, and the PowerPoint slides they have accompany things are just white with black lettering on them. They might as well be showing you a Word document, right? There's nothing to catch your interest. There's nothing to make you think. There's a bunch of words, so you'll ignore them. And that is one of the first things to consider when working with PowerPoint is anytime you put words in your PowerPoint presentation, just keep in mind that this sort of software was designed to accompany a speech. So if there's words in the presentation, people will ignore what you're saying to read the words off the screen. And then that thing everybody's probably seen before where the speaker reads from the PowerPoint. Most of us read quicker than we talk. So usually when that happens, the audience, people listening to you start to get really bored. So that's the two key points is you want to try to minimize the number of words you put in there. Excuse me. Yeah. Minimize the number of words you put in there. I've heard it stated different ways, like a rule of 5 or a rule of 7. So something like, I'll do rule of 5. So no more than 5 bullet points on a slide and no more than 5 words in each bullet point. So that way it's probably not even full sentences. The people listening to your speech will read that very quickly and go back to listening to you. And the other thing is if you're speaking along with it, you probably don't want to say the same words that are written down there, because that'll leave your audience really, really bored and thinking that, when you say something, they'll be like, yeah, I read that on your slide 3 minutes ago. I think most of us have probably experienced that. So be careful with things like that. Pictures are better. It takes a little bit of practice. That old saying, a picture is worth 1,000 words. So whenever you're putting the PowerPoint slides together, keep that in mind. More pictures, less words. I guess the quick way to put it. But it's for presentation things. So we fill up these slides, sort of a slide deck. If you've ever seen the old projector things in history books, I guess, there was like a round carousel of pictures on a projector, and a little button to click. And every time that you click the button, that carousel would turn a little, and the next picture would fall in place in that projector to be broadcast on a screen or something, to show on a screen. So the term comes out from that, each slide for the projector. And we just fill them up with pictures, words, video, animations, lots of things we can do. And then play the pictures to accompany a speech. Show pictures to accentuate the things the points we want to make. In a business meeting, show charts and graphs. Show sales going up and expenses going down, things that make the managers happy so they'll give you more money for your projects. That's going to show up a lot in the world. And pretty much all of your classes, you're going to end up needing PowerPoint for something. Right? A very common thing is group projects, where several people get together, work on something, and then present their work to the rest of the class. And PowerPoint is for making those sort of presentations, all showing people your research and what you learned. So we fill it up, and then I guess the key point is under the tab for slideshow. You can just run the slideshow and kind of click through it. Then things take up the full screen, or ideally the design is to take up a projection, be projected, or follow screen. So compared to some of the other Office software, most people feel PowerPoint's a lot easier to use because we're just dragging pictures around. So most of what you're going to do is under this tab called Insert. So things show up, just kind of click on spots and start entering text. So unlike a Word document, it's not ready to put text in. If you need to write text, you have to come over to Insert and add a box to put some new text in. Put new text in with a text box. The colors didn't come out so good, but we have to insert a spot to put text. It's just a blank canvas to draw on is what we have. So almost most of what we're going to do is under the Insert tab. On the home, I'll click the button. We can add new slides. That'll work. Give me a blank place to add things. And you probably want to insert pictures. So, like I said a moment ago, a picture's worth 1,000 words. If there's a picture that can express the point you want to make, it's much, much better to put the picture there and leave the words off. I'll just click a random bird, picture, hit insert. Hopefully it won't take too long. There it goes. And just bring in a picture, put that where you want it. We can do more than that though. We can come in and add a bunch of effects to it. Make it look nice. Wherever we want. Lots of editing options. So that is, that's just spending time with it. So that's just clicking around buttons, seeing what all the buttons do. A lot of times though anymore, it's not, PowerPoints aren't necessarily used for going through a projector onto a screen to accompany somebody giving a meeting. We're actually going to send people PowerPoints as a document. One of the things you might want if we do that is to add buttons in. We can do it on any of our shapes, but if you go to the Insert tab and under Shapes, down at the bottom, there's a bunch of options for buttons that have all this stuff pre-built in, and we can include hyperlinks, ways to jump to something else. We could jump to another slide or a particular web page. I'll just put in our course website for the example, or we could set it to run another program. It's just we could set that a button to launch Microsoft Word, play sounds, anything we want a button to do. It's just built right in there. Then whenever we're playing the slideshow, which we can also hit F5. That's pretty consistent. And then just click the mouse, hit the space bar or arrows. The arrows are nice because the right arrow will go to the next one. And then with the left arrow, we can go backwards if you're familiar with that. And then that button will link to another page. Kind of slow because of the Zoom call, but y'all can see it open the browser there. That's probably enough on that example. I just wanted to point towards the button. But we can put in buttons to do stuff. That's a very useful one. We can animate things. So under insert, if we want to add text, like I said, point out, we have to actually put a place to write text. There's not just, it's a blank sheet. It's ready to add stuff to, but don't necessarily have anything there ready. Lots of different ways we can add stuff. Audio and video. You can link to a YouTube video, or you can download videos and save them with the PowerPoint if you think you might not be online. Same thing with audio. This feature is kind of new. I haven't really used it much. It hasn't been around for too many versions of PowerPoint, but we can record stuff on our screen. So a lot of teachers use PowerPoints in their class lectures and stuff. So you can just hit that screen recording button, and when you're building your PowerPoint, just choose the section of the screen to do stuff in. And then hit the record button. Oh, well, it'll start here in a second. 3, 2, 1, yeah. Then there's stuff going on in the screen. I have a little ink pen so I can draw there. Oh, nope, that did not draw like I was thinking it was going to. I'll go ahead and stop it. But when you stop the recording, I don't know how well that worked out because there was multiple screen shares going on at once there. But then in your slide, you can just record what's going on the screen. So that when it plays back, slideshow, go to the first one, on the next one, yeah, play that recording, which wasn't really doing much. I was only half paying attention to things I was clicking anyway, but that can be a really useful feature. It brings back that original purpose of a PowerPoint is a presentation designed to accompany a speech. So you can give that speech and record that speech and put it right in there. Which is also, yeah, there's a tab explicitly for that. Record the screen, record the slideshow, and dictate it while you're recording it. I haven't really used this one yet. So this button's in the latest version, but there's forms. So we can have people fill things out on the PowerPoint. I haven't really used that and like give the people that would be looking at it a quiz, put together a quiz that they can take and have the computer automatically grade it, or some sort of form to collect data from the people that would be watching the presentation. Very, very useful things there. I'm a big believer in this is an active subject and we learn best by doing it. So yeah, you can go in and click those buttons. In our modern world, obviously, there's a lot of streaming going on, right? We can stream stuff on most of the social media sites and constantly watching each other's streams, so you can send your PowerPoint directly to one of your streams somewhere. There's a lot of setup for that, and I don't have any active, so I can't really click on anything to show that. But if you stream, like if you stream to some of your friends on Discord or Facebook or something, you should have all the links to copy and paste and set that up so that you can include your PowerPoint right in that. I guess with the pictures, animations are nice. Right? We probably don't want, still pictures are boring. Right? It was new and amazing in the 1860s. Around 1900, they figured out that if you put lots of pictures together, it starts to form videos. Things grew and grew and grew, and nowadays it just seems like still pictures are boring and seem a little unrealistic. So there's pre-built things so that the animations just kind of happen. So it like fades in over time. I don't know why that was playing. I didn't want that to autoplay. I went to click that one. There we go. Bring that in, or one I like here down here at the bottom of the motion path. Instead of using the pre-built one, we can just draw a line. So like maybe that starts down here, comes way over here. That picture of the bird will kind of fly all over the place as it comes in. That was really, really quick. So maybe that should have taken like 5 seconds. And you want to look for little things like that to make it look nice. So like a picture of the bird looks like it's flying around. I don't know why that's playing. Let's preview this one. Delete that so it stops playing. I just wanted to point at that. Right, now preview the animation. There we go. So, and move your pictures around so that it's not so static and seems a little more alive. Right? Things in the real world aren't stationary. So very subtle effects like just shaking a little bit. That was more than I meant to. Just a little bit of shaking makes things seem more natural and alive. And that might fit in some things depending on the presentation. You want to adjust it for the thing. Just remember the original point of PowerPoint was to accompany the words that you're saying. It's pictures to go along with the words you're going to say. So don't put the words you're saying into the PowerPoint. People get very bored with that. And make sure you're using pictures that accentuate it, that emphasize and accent things. But otherwise, it's kind of like the rest of the software. When you get to lab time, you just want to click around on things, start to put slides together, get some practice with it. Oh, one last thing before we leave here. When I started a new one, I skipped the blank one and went over to one of the themes, because we probably don't want to start with a blank one, or even if you start with a blank one, something you're often going to want to do is, I think it's under view. Yes. Microsoft PowerPoint, under view tab, there's this button called slide master. And any of our presentation software is going to have this slide master button. And what that is where we set up those themes. So any changes I make to this will apply on any, so if I just move that down there and I thought there was another little save button here. If I close that, notice that here where I created a new slide, that little red thing moved over now. And if I go create a new one of the same type, so that's where we change the themes. So you'll often want to do that, even if you start with a theme. So on the PowerPoint, it's under View, and the slide master, and then all of your types of slides, you can customize what they look like, how the layout is. That way everything's consistent all the way across. Basically, that's where you go to put the themes together. It's just somebody's already done a lot of that. And while we're talking about themes, I see the button right here. Remember that in Microsoft stuff, especially, they already paid a bunch of professional designers to assemble shortlists. So we can always check the short list of colors and fonts and things like that that go well together. And yeah, just keep that in mind. It takes a little while, a little bit of practice, and to get used to it. And then it's more like the traditional visual art forms, like painting a picture. It takes a little while to get the picture just exactly like you want it. So on your way through classes, make sure you give yourself plenty of time to put a really nice PowerPoint together. Obviously, it's very easy to use. It doesn't take long to get used to it. Most people think it's a lot easier than the other software, but like that comment I made about comparing it to the traditional art form of painting a picture. Usually it takes a little more time to put together a masterpiece than something that gets the quick idea across, right? Like that one I spent, like 10 seconds drawing a computer. It's enough to get the idea across. Nobody's ever going to call it a masterpiece though, right? It's not something, it takes a little bit of time. So make sure you give yourself plenty of time to work on those. I guess don't say that. Might as well talk about this. Are you all familiar with Lorem Ipsum? You've probably seen it around somewhere. Keep that in mind that there is just a generic filler text. So that Lorem Ipsum is just filler text. Back in the 1600s, I think, maybe 1500s, a printer wanted to see what things looked like on the page, but he didn't want content there. So he took this a page out of this Latin book that he was printing and shuffled some of the letters around so that it was pretty much just nonsense, but it was still had spacing and different size words and different sizes of fonts for the page. And it's the filler text to see what text is going to look like without any details to get lost in. So you'll see those. If you need that text just to lay things out, if you go to Google, you can just search for Lorem Ipsum generators. And there's a bunch of software that will just give you lists of random text so that you can see what text is going to look like in your layout without actually getting into it. And the browser was the next thing I was going to open because just like I pointed out when I was talking about, when we talked about document editors and spreadsheets, I'm a Google Docs user, docs.google.com/slides, I think is what it is. Oh, presentation. I had to take a guess, but Google is used to us taking guesses and corrected it. So in there's some pre-built things. I'll just click on blank one this time. All the same, it's very similar to what we saw when we looked at document editors and spreadsheets. The functionality is there. Buttons are in different places. By design, any of the Google Office suite is designed to be transmitted across the internet. So a lot of things are off by default. So remember to come check the add-on buttons for features that might not be turned on by default. Under slides, that where it was? One there. Why does the menu keep disappearing on me? Yeah, all the same features are there. I was looking for that master slide button, but it wasn't where I thought it was. That's something you definitely want to do in Google Docs because the templates don't look quite as nice as the PowerPoint ones. Something I find myself doing a lot is is opening one of the templates in PowerPoint, and Google Docs is compatible with that. So then I'll just upload that to save the file and reopen it with the Google Slides, so I have that nice Microsoft template on Google Docs. And what I especially like about this one is just the point that in our modern world, probably want to keep in mind that if people are watching your presentation, a large number of them are going to be watching it on their phones, right? So with Google Slides, it's really easy to check that and make sure that the presentation looks okay on the phone. That's a little harder to do with PowerPoint. So it's just something to keep in mind with our modern world. A lot of people are going to be watching your presentation from their phone. So keep that in mind, and have a you can check it here. The people will be watching stuff, looking at presentation software a lot more than your documents or spreadsheets. They're much more likely to look at your PowerPoint than they are to look at your document from their phone. So you often want to check that as much as possible. It's kind of hard to do. Oh, there's that button. So if you go to Slide, and they relabeled it. It used to be called Master Slide. On Slide, Edit Theme. I guess it's in the same place. I should have clicked on it a minute ago. This is like the Master Slide button. Any changes we make here will apply to all the other ones. So if we like change the background color, or change the font size, I'll just add some blue in there. Yeah. If we change that, should save automatically. So when we go back, now all of the slides are going to have that big blue bar. So you often want to keep consistency in mind as well, because all of those slides, even though they're separate things, they do go together. So you want to make sure they look like they go together. And let's see, 7:15. So that was about the time I wanted to try and wrap things up. That way there's plenty of time to mess around, because PowerPoint is something you will use quite extensively. So just like we saw last time, there's a MacBook version. I think theirs is just called Present, the Mac OS one. I always say MacBook because that's what I have sitting on my desk there. And that open source software, the open source stuff has that nice advantage of it's fully customizable. Whatever we need that software to do, we can go in and edit the source code, not just adjust our plans to make to figure out what works with the software. We can change the software to fit our needs. So open source stuff is nice. That LibreOffice that we looked at with spreadsheets and documents, and databases, that has a presentation software as well. But yeah, I was thinking it'd be about 5 or 10 minutes further along, and I wanted to make sure there's lots of time to click around on PowerPoint, because that's something you're going to use extensively. It'll show up in lots and lots of your classes, so you want to get some practice with that. As always, it's an active subject. We learn by doing. So that leaves us an hour and a half here to do stuff. And PowerPoint, click around for an hour and a half on PowerPoint, and you will put some really nice stuff together. Test some features you haven't used before. See what's there. That's my recommendation for lab time tonight. Yeah, there's not a whole lot we can do in the operating system stuff. My second direct, the first alternative for lab time tonight is in Ivy Learn, the module 6 stuff. We're in module 6. Yeah, there's a video about installing Virtualbox and running virtual machines. That will be a wonderfully useful tool as you progress through your education, because if you're working on a fake machine, there's no worries about breaking it. If you break it, you delete it and install a new one. And your real machine is still perfectly fine. So you don't have to worry about damaged things, so you can experiment and try things and see what's available. So that, I guess that relates to operating systems, but it's an active subject. Learn by doing. So for the next hour and a half, please spend this time that we're scheduled to learn IT, learning something about IT. As always, I will be sitting here until 8:50, ready to answer any questions. Does anybody have any questions? So if not, that's what I had in my, that was everything I had on the list for this evening. You all have a great night. I'll be sitting here. If you have any questions, text messages and Ivy Learn messages make noise on my phone. So that's the quickest way to get a hold of me. And I will see you all on Tuesday. Everybody have a good weekend.